This question say diagram 7 shows a formation of covalent bond in ammonia molecule. Ammonia is NH3, right? So what happens is ammonia molecule is a covalent compound. Okay, so you got nitrogen and H. Both are non-metals. Like because the electron arrangement for nitrogen is 2.5, means you have 5 valence electron. Hydrogen means 1. So what happens is nitrogen will donate, I mean not donate, but will share 3 electrons to H. H will only share 1 electron. Okay, because they will share to each other. N will share to H, H will share to N. But because H only got 1 shell, the first shell maximum only can fill up 2 electrons. So after you got the formula right, because if you want to get formula right, you have to see 3 and 1. After that, you cross, you become 1 and 3. So you will get NH3. NH3. But why they ask again type of bond? So to be more precise, all these 3 is actually single covalent bond. Single means they will only share to each other 1 electron. H will share to N1. N will share back to H1 electron. Unless sometimes you see like this. You see carbon dioxide. That will be different. Carbon dioxide, they will share 2 to each other. You got 2 pairs. 2 pairs means carbon will share to oxygen 2 electron. Oxygen also will share back electron, also got 2 electrons, share back to carbon. So this one is called single covalent bond. And they ask the second question, this molecule has the same type of covalent molecule, that means covalent bond, as ammonia. So they ask to draw an electron arrangement for X to Y, where X, the product number equals to 1, Y equals to 8. So it means, actually, X is hydrogen, because hydrogen also got 1 proton, right? Only got 1. Y is 8. The electron arrangement is 2.6. Actually, it's oxygen in this case. So, which means, actually, these 2 things combine together to form H2O. So, in essence, X and Y, X is 1, Y is 2.6. So, because chapter 5 also require a lot of electron arrangement. Remember the electron arrangement. Very important part also. So X we share 1 electron, Y we share 2 electron. Then in this case, X donate 1, right? Donate 1 again. Sorry, don't donate. Share. Okay, covalent always share. Unless ionic is donate and receive. This one is just share. But if you want to get formula of X and Y, then 1 and 2, right? You always have to switch. If you want to get a formula to get 2 and 1. That's why the X got 2, your Y got 1. It's an equivalent to H2O. H got 2, Y O got 1. But we draw the X to Y lah. Okay. So it means what it means, since you got 2 X, it means you have to draw left and right X. Then in the middle, you draw Y. Like this. So I draw for you lah. Basically, like this. This is, let's say this Y. Then left, you got left and right, you got X. Okay, so this is X. X, which is the 1 electron one. Okay, but the electron is already shared to inside. Shared to here, right? So you don't need to draw any electron outside because it's already shared to Y. I already share to Y. So meanwhile, Y is in the middle, but you have to draw one more shell. Because in this case, Y you got two shell, 2.6, right? So the Y 2.6, but actually now it's not 2.6 anymore. It's still 2.6, actually it's 2.8. Okay, but you don't draw here, because okay, okay, sorry, you have to draw here. Okay. You calculate first. Draw carefully. Sometimes outside is empty. Sometimes in this case, you got electron. Because you can count 6 electron, 6 valence electron. So I draw first, because it will share only one, right? Each X only will share one. Each Y also. Okay, it will share two. But the two is means it will share one to the first X. It will share another electron to the second X. That is, so each only share one. So it means I just draw one. One here, one here. And the rest, you still got, after 6, right? After share 2, right? You still got 2.4 outside. So you still got 4 outside. This is Y. X different. X I use dot to represent. Only here is already shared. Because X is just 1. After you share to here, outside, this one, outside is empty. Be careful. Like this. 2 marks. When ammonia gas and hydrogen chloride are mixed, white film of ammonium chloride is formed. Write the chemical equation for the reaction. So ammonia is NH3. Just like I told you, right? NH3. Hydrogen chloride gas means hydrochloric acid, containing H plus Cl minus. So it's like you react with HCl. Now what happens is, in this case, it will form. Now because actually between, let's say this NH3, this one is your NH3. NH3. Now, and between NH3 and hydrogen ion, because N is 2.5, after share 3 electron to H, isn't it you got 2 more extra, 2 more valence electron that is extra, that is unused. In here, this is called lone pair of electron. In Malay, it's called electron pasangan bebas. Pasangan electron bebas. So in this case, you got 2 extra. It can directly share to the poor hydrogen. Because, poor hydrogen ion. Because what happens is, hydrogen has 1 electron. After donate become H plus, it becomes 0 electron. So this guy is poor. So this guy unable to share electron to N. But normal, right? Normal covalent bond, like just now energy, right? N will contribute electron to share to H. H will also contribute electron to share to N. But in this case, the H plus unable to do so. The contribution for sharing only come from one atom, which is nitrogen. He is the very kind guy. Meanwhile, this guy is just waiting for the people to share to him. So this one is called one-sided contribution. It's also kind of a covalent bond, but in more specific, it's called dative bond. Or another name is called coordinate bond. But normally use dative bond. In Malay, it's called ikatan dative. It's like a dating. Because let's say you assume hydrogen is your girlfriend. In normal circumstances, normally the N is the boyfriend who contribute more. Normally need to contribute more. It's not anything special, but it's just that normally carry more responsibilities. Okay, so to share more. So yes, and it means when ammonia NH3, when you react with the hydrogen ion, okay, NH3 react with H plus, it will form NH4 plus. If they ask you to draw the structure, it looks something like this. Okay, let's say this is NH3, right? NH3. Then you can draw an arrow pointing towards H. Then outside you draw positive charge like this. This is NH4 plus. If they ask you to draw the structure of this native bond. So it become NH4 plus. Now you got NH4 plus and you react with the Cl minus. So that's why you form NH4Cl. Because the charge is 1-to-1 cancel off. This is the equation. Understand? This one, which we get white film coming up. Ammonium chloride consists of ammonium ion and chloride ion. Just like right? Actually, it's ammonium ion and the chloride ion. So they literally told you here, ammonium ion are formed from dative bond. Just not the NH4 plus. Formed from the ammonia NH3 and hydrogen ion. Just now I told you the story, right? So between, they told you between ammonia NH3 and hydrogen ion from acid. Describe briefly the formation. Okay, so how do you form the dative bond? It's very simple. First of all, we talk about the lonely guy. I mean, not to say lonely, but it's the unused, it's a free pair of electron. We call it lone pair of electron. Lone pair of electron. Malay is called pasangan electron bebas. They are not involved in covalent bonds. On nitrogen atom in ammonia will share to hydrogen ion that do not have any electrons. We share the poor guy. The extra pair will share to the poor guy. Unlike the normal covalent bond, normal one, you share to me, I share to you. Both sides have contributed to share to each other. This one is just one-sided contribution. Only one person is rich. Other person just waiting for people to share to him. Next, table 7 shows some properties of substance R as T. So you look carefully, all of this they are talking about solid in room temperature. But for R, when we talk about the solubility in water, for R, soluble, for S, insoluble, for T, soluble. Then, which one can conduct electricity in water? R cannot. Okay. S cannot. T can. So, in this case, now, first of all, if you see, right, in this case, right, so for this case, based on the information in table 7, identify compound R, S, and T. This question will be slightly tricky. So we analyze all these are in solid form in room temperature, but some of them soluble, some of them insoluble. And not everybody can conduct electricity. Now, just remember that in this case, T, if you see can conduct electricity, is already a very big hint. So soluble in water can conduct electricity. It means already talking about T is an ionic compound. Isn't it very obvious? Okay. So if they ask what is T, T, you already can say anything lah. Anything that is ionic compound, like for example, potassium nitrate. Not even potassium nitrate, the simplest one. If you just simplest, the simple man, then you can just say, of course, the favorite sodium chloride, the NaCl. Is it? In Malay, it's called natrium chloride. Can, yes. Or if you don't want, you can also talk about copper 2 sulfate. Can. Okay. Or in Malay, it's called cuprum dual sulfate. Can also, your wish. Okay. But for R and S will be slightly tricky. R and S are, okay, I'll talk about R first. R, solid, soluble in water, but it do not conduct electricity. Now, normally if you see do not conduct electricity, they already consider as covalent compound. You already know lah, okay? So I talk about R can be covalent compound. Yeah, or even S, right? Isn't it? But you must be, I thought covalent is insoluble in water and soluble in organic solvent. Now, there are some that is soluble in water. When is the case? When the covalent compound can form hydrogen bond. If you still remember what is the concept of hydrogen bond, remember, like the simplest example is the water. Right? Water can form hydrogen bond with another water. Why? When hydrogen bond will be formed? When? If your inside a molecule, you have either HF, HO, or HN, the bond. Since water got HO, right, inside molecule. So it will form hydrogen bond with another molecule. It means the H from one water molecule will form a hydrogen bond with O from another water molecule. This is called hydrogen bond. Hydrogen bond. Okay. So what are the example? What do you think are the example? Normally can be either C6H12O6 glucose. Glucose is one of the best example actually. Glucose. Actually, even ethanol can accept. Or even like in bio, we learn like urea, sucrose, for example. But normally we accept glucose in SPM. Or even ethanol also possible. Okay, because glucose got HO bond inside. Inside the structure have OH bond. If you see any OH bond, normally soluble, even though it's a covalent compound. This one is a bit tricky sometimes. And Sam gonna come out in the tricky question. Can? S. Okay, S. You got two choices actually. Now, number one, you can be either covalent compound. Okay, covalent because cannot conduct electricity, insoluble, right? But the rule is it is in solid form. It is in solid form. Okay, okay, by the way, I won't say ethanol. Actually, ethanol cannot be accepted. I don't think the best is ethanol because ethanol exists in liquid. So I would say glucose is the best. Glucose is sugar, right? So I say glucose is the best in our syllabus, which is in solid in room temperature. Okay. Number S is also solid, solid, okay, but insoluble. Now, normally like carbon dioxide gas cannot, Carbon dioxide gas in room temperature is gas, so not acceptable. So it's now is it a bit hard, right? So the answer that can be accepted normally is the giant covalent compound, like diamond, like silicon dioxide. Actually, it's possible. It can be silicon in Malay it's called silicon dioxide, which is SiO2. That one is a sand one, right? Sand to make your glass one, to make your kacha. Okay. Or you can put diamond also can be answered. Diamond in Malay is called berlian. Can. They are all insoluble also. They are also cannot conduct electricity, but they are in solid state. Instead. So this is one of the idea. But which we also have one exception. In this case, okay, that normally students don't see. That it can be also an ionic compound. It's possible. Okay, it's possible, but the ionic compound is insoluble in water. But teacher, normally I thought ionic compound should be dissolved in water. But not every salt is soluble in water. Like example, the red example. You know the halogen? Yes, they are mostly soluble, but except when they mix these three positive ions, like lead-2 ion, silver ion, the mercury ion. Like example, lead-2 iodide, lead-2 bromide. In this case, they actually insoluble in water. I say slightly soluble, very hard to solve, very hard to get soluble, very hard to dissolve in water. That's why if it's very hard to dissolve in water, it means very hard to turn to ion inside the water. It means you won't form the ion. If it cannot form the ion, then do you think it can conduct electricity? Since it only form the precipitate, let's say this is water, it only form precipitate, but there's no ion inside. The whole thing is just PbI2. Doesn't split into Pb2 plus and I minus. So in this case, even though I know ion is supposed to be conduct electricity, but in this case, because it cannot dissolve, it cannot turn to ions, that's why it also cannot conduct electricity. Because there's no free moving ion inside. It only has the solid, the whole PbI2. So the answer for S should be this. I know it's a bit complicated, but just want to explain why the answer scheme sometimes is like this. Of course, you have silicon dioxide also. Okay, can be accepted in English it's called silicon dioxide or even the diamond. Brilliant. Okay, you can also talk about the giant covalent molecule, which is possible. Yes. Second, this one is a bit more related to Form 4, Chapter 6. Ahmad conducted an experiment to study the properties of compound. So he has mixed compound S and T together in one beaker. Okay, so let's say assume S is lead-2 iodide, T is potassium nitrate. So you got these two salts. They are mixed together. Okay, so how do you separate the mixture? Okay, in this case, it means S is an insoluble solid. Meanwhile, T is a soluble salt. So how do you split them? Even when you cook Maggi mee, when you want to get the dry noodles, you know what to do, right? After you cook the noodle, how do you split? You have to use filter. Okay, very simple, right? So yes, but first of all, you cannot just put solid. Can you cannot just put out solid and solid mixed together. Cannot. So you must put in water. One of them will dissolve in water, which is the T. This one will not dissolve in water. Then you take this out from the water. Because the story is they mix these two solids together. How do you separate these two solids? So when you put inside water, only one of them will dissolve. Then then you use the filter to take this out. Okay, so in this case, you add water into the mixture and you stir using glass root. Then you filter the mixture using filter pump and filter funnel. Then the precipitate is S. Then the remaining solution is compound T.